Welcome to this explainer, where we're going on a bit of a journey to decode the ultimate mystery, which is, well, human behavior. You know, we often picture psychology as just sitting on a comfy couch and talking about our feelings. But in reality, there's this massive, rigorous methodology operating right behind the scenes. So today, we're going to play the role of scientific detectives. We're going to completely unpack the exact methods researchers use to figure out why we do the things we do.
I actually want to kick things off with this incredible quote from our source material. Gautam Buddha once said, "An idea that is developed and put into action is more important than an idea that exists only as an idea." I just love that, because it hits the nail right on the head when it comes to modern psychology. It's not some soft, theoretical art where we just sit around pondering abstract concepts in a vacuum. No, it's a highly rigorous, systematic, and applied scientific endeavor. It is literally all about taking ideas about the human mind and rigorously testing them out in the real world.
Okay, let's dive into our roadmap for this explainer. We're going to break this whole thing down into 4 logical steps: the motive, the blueprint, the evidence, and finally, the toolkit used to crack the case.
Section 1. The motive. The goals of psychological inquiry. So before our psychological detective can actually solve a case, they need to know what they're fundamentally aiming for, right? What is the actual point of studying human behavior? Well, every psychological inquiry tries to hit 5 core goals. First up is description. You have to accurately define and record the behavior. If you're studying study habits, you got to describe exactly what that means. Is it attending classes, revising daily? Second is prediction. Once you understand a behavior, you can forecast it. Like if a kid studies more, you can confidently predict they'll get better grades. Third is explanation. This is hunting for the why, the causal factors. Why do some kids study more than others? Fourth is control. If you know the cause, you can make changes. You can reduce a negative behavior or boost a positive one. And finally, number 5, the ultimate goal, application. This is where we bring about genuine positive changes in people's lives, like, say, using meditation to actually reduce daily stress.
Moving on to Section 2, the blueprint, the steps of scientific inquiry. You see, science isn't just defined by what it investigates, but by how it investigates. It absolutely requires a systematic procedure to maintain pure objectivity. And by objectivity, I mean 2 independent researchers should be able to arrive at the exact same conclusion. Think of it kind of like measuring a table. It doesn't matter who is holding the measuring tape, the table is always going to be the same length. To get that level of objectivity, psychologists follow a 4-step blueprint. Step 1, conceptualizing a problem. The investigator narrows their focus and formulates a testable hypothesis. Step 2, collecting data. This means building a detailed research design. Who are the participants? What tools are we going to use? Step 3, drawing conclusions. Here, the researcher uses statistical methods to figure out what the data actually means and if it proves their hypothesis. And step 4, revising conclusions. Because science is continuous. If the data doesn't fit the theory, well, the theory has to be revised and tested all over again.
Section 3. The evidence, the nature of data.
If we're out there collecting data, we really need to understand what psychological data actually is. It's not just some independent entity floating around in space. It is deeply tied to context, the physical environment, the social setting, the exact time a behavior happens. I mean, think about it. You behave very differently alone in your bedroom compared to sitting in a packed classroom, right? To capture all this nuance, researchers gather evidence across 4 main categories. Demographic information gives us the background, stuff like age, gender, caste, education, family income. Physical information looks at the environment itself, housing conditions, or ecological factors like living in a desert versus a forest. Physiological data gets literally under the skin. We're talking heart rate, electrical brain activity via an EEG, blood oxygen, sleep duration. And lastly, psychological information, which covers the whole shebang, from intelligence and creativity down to deeply subjective emotions, delusions, and illusions.
Now here's the crucial point. Not all evidence can be measured in the exact same way. For a huge chunk of the 20th century, psychology leaned heavily on objective measurement. They focused strictly on overt behaviors that could be easily observed and crunched into numbers in a lab. But recently, the interpretive paradigm has really stepped into the spotlight. This paradigm argues that, honestly, human behavior is just incredibly complex. If you're trying to study how someone experiences a truly unique, devastating event, like an earthquake or a prolonged illness, rigid objective measurement isn't just undesirable, it might be impossible. So the interpretive paradigm focuses instead on how individuals subjectively experience and find meaning in their own unique realities.
And that brings us to Section 4, the toolkit, methods of psychological inquiry.
So how do psychologists actually go about gathering all this data? What are the specific methodological devices sitting in their toolkit? Let's open it up, starting with observational methods. These usually fall into two buckets. Naturalistic observation is, well, exactly what it sounds like. You observe behavior in real-life settings as it naturally happens, like watching kids play on a school playground or observing patients in a hospital. The researcher just watches, they don't interfere. On the flip side, we have controlled observation. Sometimes the real world just has way too many variables, so researchers bring the subjects into a laboratory setting where they can tightly control the environment and isolate the exact behaviors they want to look at.
But wait, it goes a layer deeper, because the observer also has to decide how to observe. In non-participant observation, you're watching from a distance. Imagine putting a hidden camera in a classroom. The subjects probably don't even know you're there. Then there's participant observation. This is where the researcher actually joins the group, establishes a rapport, and becomes part of the environment itself. But there is a massive, massive risk here: observer bias. There's a popular saying in psychology, we see things as we are and not as things are. A researcher's own personal values and beliefs can deeply skew how they interpret the behavior they're supposedly just observing.
Okay, let's take all of this out of the abstract and look at a real-world application. I want to ask you a serious question. What would you do if the room you were sitting in suddenly started filling with smoke? You'd probably say you'd jump up and report it immediately, right? For sure. Well, let's look at a thrilling and kind of famous experiment from 1970. It was conducted at Columbia University by psychologists Bibb Latané and John Darley, and they tested this exact scenario.
To really grasp their experiment, we first need to quickly understand the experimental method. Experiments aim to establish a cause and effect relationship. The cause is what we call the independent variable. This is the factor that the researcher actively manipulates or alters. So, in Latané and Darley's experiment, they sent college students into waiting rooms to fill out some questionnaires. The independent variable they manipulated? It was the presence of other people in the room. Some students were put in a room totally alone, some were put with other clueless students, and some were placed with actors who were secretly instructed to just sit there and do absolutely nothing.
Now, the effect that they're measuring is called the dependent variable. This is the behavior that changes because of the independent variable. So once these students were sitting in the rooms, the researchers started pumping thick smoke through a wall vent. The dependent variable, the specific effect they were watching for, was how frequently the students got up, left the room, and reported the emergency.
And the data they collected was absolutely wild. In the control group, these are the students who were completely alone. They reported the emergency 75% of the time. Makes sense. But check out what happens when the independent variable changes. Experimental group 1, who were placed with 3 other naive students, only reported it 38% of the time. And experimental group 2, who were waiting with 2 passive actors pretending nothing was wrong, they reported the smoke a mere 10% of the time. No way, right? Just 10%? There is a stark, honestly terrifying decline here. As the social variables changed, literally just adding more people to the room, the likelihood of a person taking action absolutely plummeted. It is such a powerful demonstration of how our context completely dictates our behavior, often entirely outside of our conscious awareness. Now, for Latané and Darley to legitimately prove that the presence of others was the true cause of this decline, they had to be incredibly careful. Because to prove cause and effect, you have to eliminate extraneous variables. You got to rule out the noise. They had to ensure that the room size, the temperature, the total amount of smoke, and the exact speed the smoke entered the room were completely identical across all the different groups. If the smoke had entered one room even a little bit faster than another, the whole experiment would have been totally invalid.
So, how do experimenters ensure their conclusions are absolutely watertight? They use strict control techniques. Elimination means removing a variable entirely, like using a soundproof room to eliminate outside noise. If they can't completely eliminate it, they use holding constant, like making sure the temperature is the exact same for every single person. Matching involves pairing participants with similar backgrounds across the different groups. Counterbalancing changes the sequence of tasks so that people don't just get tired and skew the results. And finally, random assignment. This ensures that every single person has an equal chance of being put in the control or the experimental group, which effectively eliminates systematic differences between the groups. We've seen exactly how scientists investigate behavior, but what about you? As we wrap up this explainer, I want to leave you with one final thought. The next time you take a pledge to, say, control your diet or study more, and then you fail to do it, don't just sit there feeling guilty. Become a scientific detective of your own life. Ask yourself, why do you feel what you feel? What extraneous variables are quietly influencing your daily decisions? And more importantly, how will you systematically investigate and change them? The toolkit is now yours. Thank you so much for joining me on this explainer.